Okay, so the law of sines is set up like this. So you have three fractions are all equivalent. The sine of angle A divided by little a, which is the side opposite angle A, that ratio is the same as sine capital V over little b, sine capital C over little c. Um, so you want to find a known angle side pair. So in this case, angle A is 58 degrees, right? Angle B is 76 degrees, right? And by the way, if you know two angles, you know the third angle. Just use a calculator,
Uh,
which is 46 degrees,
okay.
and that's 8. So what you do is you already know that 46 and 8 go together. So you write that out, and they're asking us to solve for little a. So 58 and little a go together. And then you use a calculator to work it out, or you can cross multiply first if you want to wait till the end to use the calculator. So little a is going to equal 8 sine 58 degrees over sine 46 degrees. And we work that out. You should get 9.43.
Okay.
So it's pretty straightforward. You just use a formula, plug in things you know. And the bottom line is you don't have to get so carried away with all the letters. You want the angle and side to match up, and you're just trying to set up a ratio. So you could use this for any triangle, especially non-right triangles. Um, Now, where does it come from? If you were to drop an altitude like this and call this H, if you think about, let's focus on this triangle right now, right? Um, Sine of angle A is H over B, right? So the height equals B times sine angle A. Also, if you focus on this triangle, sine of angle B is little h over A. So you have that. So both of these equal H, right? That equals H, and that equals H. So if you move things around, divide both sides by little a, divide both sides by little b. That's why that equation works the way it does. It starts with the basic SOHCAHTOA rules. And then if you were to, flip the triangle around and instead of C being the base, like maybe B or A is the base, you can see the same relationship will happen with sine of angle C over little c. And so they all equal each other. So that's
I
what you do. So it's a pretty straightforward process. So like here, we don't have a triangle, but you could draw one.
I do not understand this.
I'm sorry, I can't hear you. What was that?
I do not understand this.
I just explained it.
Yet I did
What,
not
what,
get
what is it? What does he don't understand? What I explained?
everything.
I just showed you the formula. Just plug it in, right?
I don't understand why the formula works.
I just explained it. Like, I'll explain it again. I don't know how else to explain it. I'll explain it a second time.
Yeah, maybe
Okay.
I just need to hear it again.
Okay. All right. So you have a triangle like this, right? Okay. Maybe I'll have you explain for me then. That might be a better way. And let's call this D, by the way, this side here. Okay. So let's focus on this triangle. Okay. So where's my right angle?
Um,
What,
here?
what's that? Sorry.
Is it here?
Yeah, but what letter is associated with it?
D?
Okay, okay. So notice how I redrew it down below, right?
Yeah.
Okay, good. Now, remember what I said that the sides opposite the angle, we put a letter like that's little a, that's little b, and that's little c. Does that make sense?
Yeah.
That's probably where you lost. You probably just didn't see that. So see how little a and capital A are opposite of each other?
Yeah.
You see how little b and capital B are opposite of each other?
Yes.
Okay, cool. So if we think about it, let's go down to this triangle here. Notice how that's B and that's H. Does that make sense?
Yeah.
I'm just copying the triangle that I drew up above. So now let me ask this question. If I take the sine of angle A, what would that equal?
H?
Over.
Uh, be over.
Well, you know this. Sokoto, right?
Oh, wait, hold on, hold on, hold on. Somebody's calling me?
Okay. You
Somebody's
can.
calling me. I need to.
Do you need to take it? Do you need to take that?
No, I don't
You
need
can
to.
take it if you need to.
No, 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 I don't need to.
Okay.
You don't need to.
So you have Sokoto, right? So sine of angle A equals what over what?
H over B?
You're correct, because that's hypotenuse. And if you multiply both sides by B, what do you get?
Uh, I would get
Those cancel. So when you isolate H, what do you have on the other side?
uh B times sine A.
Good. Okay. So let's hold on to that. Okay. Does
Okay.
that make sense?
Yeah, that makes sense. That
Okay,
makes
good.
sense. That
I'm
makes
going to do the same exact thing for this triangle right here.
okay.
So this is CDB. Yeah, I think you just need to talk it out. That's probably what happened. You probably just got lost when I was going over through it. I just were this was a lot of material. So that's H and that's A. So now let's look at angle B. What's the sign of angle B?
Uh, H A.
Okay, H over A, right?
Yeah, H over A. H
Okay,
over A.
correct. So
So
H
then
equals
it's A times sine B is H.
okay. So
Okay.
clearly this is the same as this, right?
Yeah.
So that's what I did. I had to set them equal to each other. They both equal the same letter. Does
Okay.
it, and then as a last step, I'm going to divide both sides by A to get this. And also divide both sides by B. So now that's it. There's a lot of signs.
Huh.
But notice it took quite a bit of work, right? To make that
Yeah.
happen. So now you understand how it works. Now we can just use the formula all the time.
Okay.
Okay. So now, okay, they say angle C is 113. Angle B is 41 degrees. Side C is 15. So that's going to be this side. And it wants to get little a. So first off, we should probably figure out what angle A is, right? What's angle A going to be?
sine A is equal to H over A?
No. Right here. So what's angle A?
Oh, angle A. Uh, no, I put that wrong.
Ugh.
26.
Actually, it should be 36, I think. No, well, no, you're right. It's 26. Sorry, you're right. You're right. Okay. So now the sine of 26 degrees over A. See how I set that up?
Yeah.
Because that's one pair and that's another pair. And then you just use your calculator to work it out. Do you want to work it out? Do you have a calculator with you? You can use your
Let
cell
me
phone
grab it.
or
Let me grab
Desmos.
it.
Yeah, either way is fine.
All right, I have it. Um, how would I plug this in? So I would cross multiply.
Correct.
So then sine 26 times 15. So I got 6.5755, so on. And then this would be A times sine. I'm not used to writing with a mouse. So is this what the thing would be? Would I do? No. Would I divide by the sine?
You got, well, yeah, keep going. Let me know you're done.
Would I divide the
But by the
6.575?
sine of 113, correct.
Okay. So 6.575 is divided by sine 103. And I get that A is equal to 197.142. So on. Is that right?
Yeah, looks like the answer is A. Yeah,
Yeah.
yeah. Let me double check the answer key. Yeah, good. You got it. Good work. Okay, so let's do one that's a little strange. It's called ambiguous case. Have you guys talked about that?
No.
What was that?
No.
Okay, you might be doing that. Okay, well, let's do three.
My teacher said that we aren't going to get into that too much quite yet.
Will you guys this year?
I don't remember what we were on, but
I mean, it is.
he just said that we're just gonna get into only the law of sines for
Are,
now, and that we'll
are
go
you
back.
guys doing law of cosines?
What?
Law of cosines. Have you heard of that?
No.
No. Okay, so we won't worry about that then. Um, well, let me teach you what's going on because three and four are kind of unusual cases, and then we'll do a more typical case
Okay.
later on. Because so let's draw this. Actually, I don't know why I even did that. Okay, so if I set it up, it's gonna look like this, right? So go ahead and cross multiply.
Cross multiply. Okay. Nine, 1, 5. Okay. I got for sine A. Oh wait, muscle memory. I got 1 point. Oh, I wrote two equals 1.1.
You're good. Excellent. That's what I get to. Keep going.
7, 8.
That's perfect. That's enough. Yeah. Okay. So now you got to solve for angle A, right?
Yeah.
But there's a sign. How do you get rid of that? What do you do?
Uh, I'm not sure.
Okay, you probably guys haven't covered it. Have you guys done inverse sine?
Inverse. No.
You guys never done that? Like like the sine at the -1 symbol to solve an angle.
Yeah, we have.
I'm sorry, you said you have or haven't?
We have.
Oh, you have. Okay, so you do know. Okay, okay, okay. Do you know how to find the calculator?
Yeah.
Okay, so can you if you do that, what does the calculator say?
1.178. I get error.
Good, you should. So why do we get an error? Because when you're saying that the sine of angle A is a number larger than one, that's strange, right? Because let's look at a very standard right triangle, like something like this, right?
Yeah.
So sine of angle A would be 3/5 of here, right? Now it's very obvious this side has to be less than this side
Yeah.
because 5 is opposite the biggest angle. It's opposite 90 degrees. 3 is opposite an angle less than 90. So we know this fraction is less than 1. Now, when you have 1.178, you're saying that it's 1.178 over 1. So you're saying this is 1.178 and this is 1. But that doesn't make any sense, right? Because how can this side be more than this side? That just can't happen, right? So that's why you get an error. So sometimes the law of sines will give you an error. It's just not, the triangle is just not possible. Also, here's another reason why too. You have 115 degrees for that, right? Look at the side opposite of it, 15.3. That's less than 19.9. We know 115 is going to be the largest angle, right? Because you only have 180 degrees for a triangle. So 115 is guaranteed the largest angle. So it should be opposite the longest side, but clearly it's not because there's another side that's longer. That's on the other side. So um so we have to be mindful about that.
Okay.
Yeah. Right. So that's another thing that could happen, just so you're aware, in case you guys do talk about it. Now let's try another one here. Okay, so you're gonna set up like this, right? Okay, go and solve for angle B. So now you know what to do. Let me have you try right now.
Uh, oh, so I completely zoned out. 12 times. I got for sine b is equal to 0.330. That's
Okay,
what I
good. So,
got.
and then go do the inverse sine of that.
0.330. I got 19.268.
Okay, so 19.628 degrees. Okay.
Right, 268.
Hold on. Let me do it. Give me a second. I actually got 19.315. I think you rounded a little too soon. That's okay. So it's slightly bigger than 16, which makes sense because 12 is more than 10. And then you can figure out what angle C is and then solve for little c afterwards. So it's 19, we'll say 19.3, keep things simple. So that's going to be 144.7. So then you work that out. And you would work that out eventually, just as you usually would. And I'll just tell you what the answer is if I work that out. I'll just save us time. They get 20.97. Now it's interesting because I see 20.97 here and I see another side. Like, why are the two answers, right? That's kind of strange. Well, here's what's happening. So when we solve for angle B, we got 19.315, right? Here's where it gets interesting. I'm a little surprised you guys are covering this topic so early because you guys haven't done more advanced trig. But if I did 180
But we're
minus
just
19,
covering the law of sines only.
no, I know, but I'm just saying that there's just an exception to the law of signs. See, if I do 180 minus 19.315, I get 160.685. If I take the sine of that, I will get 0.330. So there's actually two possible angles for angle B. It's one of those weird things that happens with sines. Yeah, if I did sine of 160.685, yeah, I do get that. So what that means, the triangle could have also looked like this. See, that can all work, right? Because 60 and 160.685 still has a little bit left over for that angle. So whenever you do this situation here, we have to solve for the angle, you have to kind of look at both scenarios. But I don't know if you guys are going to do that. You guys may not do that. Maybe we'll do that next year in Algebra 2 or when you're um, a senior and take pre-calculus. I don't know. So Oh, yeah, and you have to remember you're a sophomore right now, right?
Yeah.
So maybe you might see that in pre-cal. I don't know, but there is still a little room left over for that. So that's 3.315 degrees. So anyhow, and then you can solve for the other side, but let's just do a fresh one here so you feel comfortable now doing this on your own. Here. Okay, let's look at number five. First of all, what does angle C equal?
Uh, let me just plus 75.
Okay. Okay, so now let's move on to solve for little a. So go and solve for a, and let me know what you get when you're ready.
Uh, I got for a 26.054. That's what I got.
Cool. Yeah, I agree. Um, and then you gotta do it one more time to solve for little c, or sorry, little b. So I'll still maintain the same relationship on the right side. Okay. Now I'll solve for little b.
Okay. Uh, 28 I got is equal to 19.017. That's the answer which I got.
Good. Okay, I agree. Okay, so how are you feeling now about law of science?
Pretty good.
Good. Okay, good. Um, okay, and sorry if I was a little snarky. I was just doing some stuff earlier today, so my apologies
Okay.
if I came off that way. There's nothing personal, just so you know. But okay. Um, yeah. So you feeling okay?
Yeah, I'm feeling okay.
Okay. Is there anything else you guys are covering?
Not at the moment.
Okay. Let me just do one more thing we could wrap up. I just want to talk about what law cosines are, and then we'll be done for today. So like number three and four, you're gonna run into a problem, and maybe you guys will talk about it, I don't know. And then you start spring break after this week.
Yeah.
Okay. So here's the deal. Um, so notice I don't have any angles here, right? I just have three sides. So it's kind of like if I could try doing the law of cosines, sorry, law of sines, but you have a problem because you don't know angle A or angle B, right? That's a problem.
Yeah.
So there's another formula. It's called law of cosines, and the way that works, it's a little bit complicated. I'm not going to do that today, unless you guys are going to talk about it. But it looks like this. So you plug in side A, which is 12. You plug in side B, which is 18. And then side A, again, 12 here. Side B, which is 18. And you don't know what angle C is. And side C is 28. Then you kind of just work it all out and solve for angle C. In fact, this would work for any triangle, even when you have law sines. Um, once you get what angle C is, if you want to solve for angle A or B, then use law sines afterwards. Because then once you have angle C, then you have a known angle side pair. But in order to do law sines, you have to know at least one pair of angle and side. Um, like this angle and this side are opposite each other. You have to, otherwise we can't do law sines. So law cosine is like another formula you can use. It could also work in the case of number four. Notice you're given one angle, but um, you're not given the side opposite of it. That's a problem also. So see how this is side, 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 and that side angle side? Whenever that's what you're given, then you have to use the law of cosines. So if I call this a little b here, then b squared equals a squared plus c squared. You put the other two sides on the other side of the equation. So that's going to be 20 squared plus 14 squared minus 2 times 20 times 14. And then you solve for side B.
Okay.
So that's another approach you can take. But I think we ended a little early today. I think we've accomplished what we need to do. And when do you start break? On Thursday?
Yeah.
Okay. So we won't meet. There's no need for us to meet next week because you're on break. But when you come back, I'll share my schedule and we could start meeting up again later in April.
Okay.
Cool. Well, okay, great. This is great. Now let me stop recording and I'll share the recording with you so you have access to it. And I'll just give you some practice problems also.
All right.
All right. Well, enjoy.